Hello. Yeah, you know the VT graph, the ST graph, and the AT graph, they are all interrelated. So given this VT graph, can we draw the corresponding ST graph and AT graph? Let's start from the ST graph, yeah? So the area under the VT graph is the change in displacement. So during the first 1 second, the area under the VT graph is 1 unit, yeah? Positive 1 unit. That means the distance traveled is 1 unit. So the displacement has to change from 0 to 1. In the next 1 second, we still have a positive area of 0.5. So that means we'll travel further by a distance of 0.5. That's why it goes from 1 to 0.5. In the next 1 second here, we actually have a negative area of 0.5. That means the displacement has to drop down by 0.5 because you are now moving in the opposite direction. So you're coming back, you're on the way back. In the last 2 seconds, we have a negative 1 area here. So your displacement has to change by negative 1. So it has to go from 1 to 0. So we have quite a few landmarks here. How do we join up these lines here? Straight lines or curves, yeah? So remember, the gradient of the ST graph is the velocity. So when we have a constant velocity here, we must have a constant gradient here. So the first 1 second is a straight line graph. But in the next 1 second, the speed is not constant. Your speed is decreasing towards 0. Slowing down would mean that the gradients on the ST graph must become flatter and flatter. So it's a curve that becomes flatter and flatter. Now in the next 1 second here, we're actually going faster and faster. So if you're going faster and faster, the gradient must become steeper and steeper. Now notice that the gradient here at this point, the gradient here must be exactly 0 to correspond to the velocity of 0 here. In the last 2 seconds, are you speeding up or slowing down? You're slowing down, yeah? You're slowing down. So the ST graph must flatten. It must become gradually flatter and flatter. In fact, the gradient here again must be 0 because your velocity is 0 here. So does this ST graph make sense? So we're moving at a constant speed and then we start to slow down. And then because we are now switching direction, yeah? The velocity has switched direction. That's why we're on our way back. So the displacement graph starts to head down, speeding up, and then slowing down. Okay, let's do the acceleration time graph now. This one is even easier, huh? The gradient of the VT graph is the acceleration. So when we have a 0 gradient here, it means there's no acceleration. Then when we have a constant gradient of -1, it means our acceleration is constant, -1. Now in the last 2 seconds here, we have a constant gradient of 0.5, so acceleration is 0.5. So we're done actually, but for completeness sake, let's try to work our way from the AT graph to the VT graph. So the area under the AT graph is the change in velocity. During the first 1 second, there's no acceleration. That's why the velocity doesn't change. It remains at 1 meter per second. Then during these 2 seconds here, we have a negative area of -2, right? -2. That means your velocity has to change by -2. That's why it changed from 1 to -1. Then in the last 1 second, we have a positive area of +1, right? That means your velocity has to change by a +1. That's why it changed from -1 to 0. That was quite fun actually, isn't it? Alright, that's all. Ta-ta!